anyway, if you haven't got that extra credit, you can turn that into me today, or even Monday would be fine. I'm continuing in section 4.5 today. There's a little bit of graphing at the beginning of the notes, but then it stops, and you don't even have any graphing in the homework tonight. So we're starting to do some different things. Before I get to the new stuff today, and you don't necessarily have to write this down because you should already have it in your notes, but I want to remind you real quick what the sign graph looks like. This is once again the parent graph because it's just sign of x, nothing happening to the x. So in general, it starts at the origin, goes up first, and then back around. Now, I didn't point this out in detail when we did part 1, but I think we've talked about it before. I'm going back to a term that we learned about a little while ago called the period. It goes from 0 to 2 pi until it starts repeating again. So the period, and we'll talk about this again today, the period was the length that it goes until it starts repeating. On the parent graph for sine and actually cosine, the period is 2 pi. It does everything right in between there. And then if you took that chunk, moved it that way or moved it that way, it would be exactly the same. The reason I'm pointing that out is because our first 2 examples today are going to be graphs that have different periods. You'll start to notice that when there's a number in front of x, which we haven't really seen yet, but we're going to, when there's a number in front of x or multiplied by x, that is what changes the period. So it may not be 2 pi on these. It might be something bigger or it might be something smaller. All right, so actually directions are going to be just to sketch a graph. And again, I've got, I think, 2 of these. This is just kind of building us up to some formulas and other things that we'll talk about later. Okie doke, so let's see the first one. Example 1 says y equals sine of 2x. We know, bless you, we know what a number does when it's in front of the function. That made it like a vertical stretch. We don't know about this yet, so this is new. Even though it's new, I'm still going to go back to the method that we've been using, which is to make an XY table. And for the time being, I'll stick with the same old x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now I'm just going to grab my calculator to type all of this in. I do want you to notice that it's sine of 2x. So you can type it in a couple different ways. If you want to leave the 2 there, your calculator probably sets up some parentheses. So you could type in sine of 2 times 0. You can type it in exactly like that. Or if you want to go ahead and actually multiply the 2 and the 0, that's just going to be basically a sine of 0. So either way you want to do it, sine of 2 times 0 or sine of 0, we should get back the same y. This is what it would look like if you went ahead and, I don't know why I did that, if you went ahead and kept the 2 there, again, you get back the y value of 0. Let me keep going. The next x value down was pi over 2. If you want to multiply the 2 and the pi over 2 first, you can, and then just take the sign of that number. Or I'm just going to kind of write it out the long way. I'm going to type in sine of 2 times pi over 2. Now I'm weird and I kind of like to put the pi over 2 in parentheses just to make sure my calculator knows that this was actually kind of a fraction that had to be together. I just need to take 2 times that number. All right, and when I do that, I get back another 0. Okay, let me keep going. Sine of 2 times the next value down was pi. So you can do 2 times pi or even just 2 pi. That's the same thing. But that, believe it or not, gives me back another 0. Now I need to plug in the 3 pi over 2. So I'm just doing this long ways. Sine of 2 times 3 pi over 2. And here come the parentheses again, which might be overboard. You may not actually need them, but I like for it to kind of stay together since it was a fraction. That gives me back another 0. And then the last x value to plug in is 2 pi. So I need to take sine of 2 times 2 pi, or if you wanted to just make that sine of 4 pi, that works too. Now you get back something kind of weird here, and I'm not sure if we've talked about this yet or not. This is actually like scientific notation. It doesn't really look like it, but the capital E right there is kind of like your times 10 part. So this is the same as negative 2 times 10 to the negative 13th power. That means I have to take my decimal and move it to the left 13 places. 1, 2, 3, 4, blah, blah, blah. You'll fill all of those in with zeros. So by the time you round that off, we're probably just going to call that 0 as well. There's probably just some kind of weird function in our calculator where it does that a little bit differently. Let's go ahead and say that last y value is still 0. Now this is strange because all of the y's are zeros. So let me go ahead and graph these points right now. And then I may have to come back to my table here in a minute and fill in some more x's to see what's actually going on. This isn't going to give me a real good picture, but we'll see what happens. I'll say this is 2 pi, so that would be pi. That is pi over 2. I'm labeling this exactly like we did on part 1. And I don't even know what to do on my y-axis yet because everything is 0. There's a point at 0, 0, a point at pi over 2, 0, pi 0, 3 pi over 2, 0, and 2 pi 0. Now we know better than this. We know sine is not going to be just a line going straight out to the right or to the left. It's not a straight line. According to our parent function, it should start and go up and then down and keep on doing the curves. So I'm going to go ahead and find a couple x values in between what I already have to try and get that nice looking curve. Okay, now I'm just going to tell you what these x's are. We're not going to have to worry about this too much until Monday. On Monday's lesson, I'll go into more detail about how to find these other points. But I'm just going to tell you today, the halfway point between 0 and pi over 2 is pi over 4. And then halfway between pi over 2 and pi is 3 pi over 4. Again, don't worry too much about that today. You're actually not going to have to do that again in the homework or anything. This is just kind of the introduction part. But those two numbers, bless you, those two numbers, I'm just going to add those to my table and then use my calculator to plug them in, and hopefully I don't get back any more zeros. Kind of tired of all the zeros up here. So, plugging in a pi over 4. I'm typing in sine of 2 times pi over 4. And thank goodness it's not 0. That gives me back a positive 1. And then sine of 2 times 3 pi over 4. That is not 0 either. That gives me back a negative 1. Now you guys have lines on your paper, but let me fill this in. Pi over 4 up to 1. 3 pi over 4, I'm down to negative 1. Now I'm just going to connect this very first part of the graph. We know that it keeps going forever and ever, and I could probably figure out where the rest of those points would be. But for right now, I'm just going to connect it like this, because this is what the parent graph looked like. It started at 0, went up, back to 0, went down, back to 0. That's what the parent graph looked like. However, and you don't really have to draw this part in, but here's what the parent graph actually did. It was up at 1 right here. It was down at 0 right there. It was down at negative 1 right there. And it was up at 0 right there. This, I'm just going to dot this in here. This is what our parent graph looked like. So what I want you to notice is the 2 that was in front of the x changed the period. The period of the sine graph used to be 2 pi. Well, that 2 being multiplied by the x, it sort of scrunched the period up a little bit, and now it only goes to pi. And then it starts repeating after that. Here in a little bit, I'm going to formalize that into a rule where you can actually find the period right away without graphing it first. But again, the point of these first 2 examples is just to kind of understand what those numbers do. All right, I'm going to try one more with cosine. And the number in front of x this time is a fraction. So, bless you. This will do something even more different to our graph. All right, it says y equals cosine of 1/2 x. The 2 scrunched it up. So the 1/2, I already kind of have an idea. It might do sort of the opposite. Now here again, I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi, at least right now. And here we go, typing these in. I would suggest, instead of doing 1/2 when you type this in, do a 0.5. That'll be a little bit easier than trying to do 1 divided by 2 every single time. So let me show you what this looks like on my calculator. I need to take cosine of 1/2 times 0. I mean, you could go ahead and multiply that out. That's the same as cosine of 0, which is just 1. Then I need to take cosine of 1/2 times pi over 2. So like last time I told you I'm weird, I like to put the pi over 2 in parentheses. You probably don't have to. But that, not as nice as the others. 1 or 2 decimal places is fine. I think I just rounded that to a 0.71. So, okay, that's not real great. But let me keep going. Cosine of 1/2 times pi, that would be the next number in my table. So that's a 0. Okie doke. Cosine of 1/2 times 3 pi over 2. 1/2 times 3 pi over 2, that would be like a 3 pi over 4 if you wanted to do that first. But that ends up being like a negative 0.71. And last but not least, cosine of 1/2 times 2 pi. That's basically like cosine of pi, and that gives me back a -1. Now I need to go back, and at least we don't have zeros for everything. We actually have some other numbers to work with. So let me graph these, and then hopefully I can see my cosine curve. I know from the parent function what that should look like. All right, I'll say that's 2 pi. This is pi. This would be pi over 2. This would be 3 pi over 2. And on the y-axis, we're going to have to just kind of estimate on the 0.7s. We'll just kind of do our best with those. But the first point is at 0, 1. Then pi over 2, 0.71. Just go up a little bit past halfway. When you go to pi, you're down at 0. Then 3 pi over 2 is almost to -1, but not quite. And then 2 pi is down at -1. The way these points are is not really giving me the full cosine curve. The parent function says that we should start up and then go down, but it should really show another part where it goes back up again. So I'm just going to connect what I have right now. I basically only have the left half of my cosine curve. I need to go a little bit further to the right to see where it comes back up. So I'm just going to extend my x-axis a little bit, and then let me give you a couple more x's to use. This is not really equally spaced here because I'm running out of room, but let's try also a 3 pi and a 4 pi. What will that give me? 3 pi and 4 pi. So I'm typing into my calculator cosine of 1/2 times 3 pi. That is a 0. And then cosine of 1/2 times 4 pi, that is a +1. So here I go. 3 pi, 0, 4 pi, 1. That is now going to show me what the whole curve looks like. Now it looks a little bit more like the parent graph. So think about this. The parent graph, I'm going to put it in red. You don't have to do this part, but here's what the parent graph did. It was a little bit shorter. It did that whole curve, but in the length of 2 pi instead of 4 pi. So to kind of summarize that, if there's a fraction in front, it stretches out the period. If there's a number bigger than 1 out front, then it kind of scrunches it, like we saw on example 1. Now, good news for you guys. We're done graphing today. That's one thing there. We're done graphing. But everything that we learn for the rest of the lesson today is going to build us up to where we don't have to make tables every single time we have to graph. In fact, today is probably the last day that we will make a table to graph these trig functions. I'm going to go ahead and give you a couple rules to use that go along with the period like we were just talking about. So it kind of sets you up here with this introduction. It says, if you have y equals a sine of bx, or y equals a cosine of bx, The A and B up there are just trying to show you that you could have a number out front or you could have a number with X. Here's the first formula. To actually find the period without graphing first, you can find the period right off the bat by taking 2 pi divided by b. That formula is very important. 2 pi divided by b. b is the number in front of x. So 2 pi divided by that number. If you go back to example 1, the number in front of x was 2. So 2 pi divided by 2, the 2's would cross out and you'd just be left with pi, and that was the distance it went until it started to repeat. So period is 2 pi over b. Now, I went ahead and put back up here just kind of a quick little reminder about what the period actually is. We've been talking about it a lot today, but in case you want that again, the period is just the length until the graph starts repeating. Length until the graph starts repeating. Okay, that right there will help us when we start to graph without tables. This will also help us. I'm not sure that I've even really mentioned this term to you yet, but there's something else that you can find out about a graph before you even graph it, and that is the amplitude. Now what I have right here is basically just the formula for the amplitude. It's absolute value of A. A is the number out front, so take the absolute value of that, and that is the amplitude. Now, just in case you want it, this is just like a definition for the amplitude. It's the distance from the x-axis to the highest point or lowest point. Distance from the x-axis to the highest or lowest point. And that word distance is why we have to take the absolute value, because distance is always positive, and that's what absolute value does. Okie doke. So the last few examples here, again, you don't really have to graph. We're just going to get some practice using these formulas. And so directions just say, find the amplitude and period. 2 answers for each problem. Find the amplitude and period. Amplitude is absolute value of A. Period is 2 pi divided by B. I'm going to start with one that's pretty straightforward. Number 3, this is our third example here, but first one of these. Y equals 4 sine of 6x. 4 sine of 6x. Now, it might be helpful to kind of match this up to where it said A sine of bx. That was just kind of the general format of these trig functions. A is the number in front, so that would be 4. B is the number in front of x, so that would be 6. Now, I'll start with amplitude, and I usually just put amp. It's a little bit easier than writing out the word amplitude every time. To find the amplitude, it's just absolute value of A. Well, A for us is 4, so absolute value of 4 is just 4. Remember, absolute value makes everything positive. Okay, when you go to find the period, we are not going to use decimals. We're going to keep everything in terms of pi. The formula said, take 2 pi divided by b. b in this case is 6. So 2 pi divided by 6. Again, I'm not going to get decimals. I don't want to get decimals, but I do want to reduce that. You could divide both of those numbers by 2. So that'll be a 1, that'll be a 3, and I don't have to put 1 pi over 3. I can just put pi over 3. That would be our period. On Monday, we're going to do this part first on every single problem, and then from there, we'll figure out what the graph looks like. We're not going to have to make tables. All right, let's try a couple more that have a little bit more thought required. Example 4, y equals -2/3 cosine of x over 3. -2/3 cosine of x over 3. Usually the only mistake people make when they state the amplitude is that they forget its absolute value of a, not just a. So a here is -2/3, but you have to take the absolute value of that, which ends up being +2/3. Amplitude should never be negative. Okay, well, I'm going on to the period, and this is where I run into a little bit of trouble. To find the period, I have to take 2 pi divided by b. B is the number multiplied by x. Little bit weird here, just because of the way it's written. So let me take this out to the side for just a second. Remember, x is technically 1x, so there's a 1 on top and a 3 on bottom. You can rewrite that as 1/3 x. So what I'm trying to say is x over 3 is the same as 1/3 x, and I like to write it that way because now I can see what b is a little bit more clearly. B is 1/3. So I'll have to take, this looks weird, but I'll have to take 2 pi divided by 1/3 to get my period. But what do we do, or what's our cute little saying when we divide with fractions? Keep, change, flip. So keep the 2 pi, change it to multiply, flip a 1/3, and you get a 3. So 2 pi times 3, that is 6 pi. Again, amplitude is pretty easy to find as long as you remember the absolute value part. The period sometimes takes a little bit of thought, just depending on how that is written. Okie doke. I'm going to do just one more here. I just have something else that you need to see before you start the homework. Number 5, y equals 1/3 cosine of pi x over 4. 1/3 cosine of pi x over 4. What would the amplitude be? 1/3. You can take absolute value of 1/3, but it's just 1/3. And then here again, I don't really like how this part is written. To get b, it's really kind of like the number in front of x, and I can't really see a number in front of x right now. But pi over 4 is a fraction, just kind of like the 1/3 was on the last problem. You could rewrite that as pi over 4x. So b is actually pi over 4. Now, by the time I keep, change, flip, this actually works out kind of different. Keep the 2 pi, change it to multiply, flip the fraction on bottom. I kind of like to put the 2 pi over 1 on something like this. So the pi's actually drop out, and you're just taking 2 times 4, which is 8. Every once in a while, the period doesn't end up with pi. If it happens like that where you've got a pi up here, then it's probably going to cross out and you just get that number. Okie doke. Any questions about that? Again, there's no graphing. The first two examples were just to show you what happens when there's a number in front of x.